Okay, welcome everyone, and thanks for coming. I'm Paul Chafe. I am the Chief Science Officer at Dandelion Networks, and what I'm going to talk about is, a much higher level than the previous talk. What is the actual value of blockchain? Because this is a term which is thrown around a great deal. Blockchain this, blockchain that. Why is this actually important? Why does anyone care? And in order to understand this, you kind of have to get into some of the details of how these things work and then what they enable and ultimately what everyone in the space is trying to build for the future. And we at Dandelion are a new layer one, and we're actually ideally we're going to be spooling up our launch for our testnet this very week. We've been working on it for quite some time. Why? Right? What's the value that we think we can add to the world by doing this project? And here it is. So the first question is really, what even is a blockchain? Again, it's a term that's used a great deal. And in the simplest form, it's really just a form of a data structure. So this is quite computer science nerdy. What you have is a chain of blocks. Each block is a block of data, just like a column in a spreadsheet. And what we do is we cryptographically link those blocks together so that if you want to change the data in any given block, you have to unravel all the blocks that come after it, right? So this gives you some cryptographic security and some proof that nothing has been changed in the system unless someone has done that process. Now, this is kind of interesting from a computer science perspective, but from a business perspective, from a human perspective, we have a very different definition, right? So a blockchain, in quotes, so not the data structure, is a secure, resilient transaction platform with the property of decentralized trust, right? So when we talk about secure, what do we mean? We mean we can't actually change it. This is the cryptographic linking part, right? We know it's secure. Resilient. This means that we can be sure that this system is going to operate even if it suffers a catastrophic failure of a large subcomponent of the total network, right? And the property of decentralized trust. This is the most important thing in the whole thing. Decentralized trust is what enables this system to have value. So if we don't have decentralized trust, really we just have something that's like a glorified database or a glorified spreadsheet. Okay. When we talk about a blockchain in quotes like this, it may or may not include an actual blockchain. Okay, like the data structure blockchain. Dandelion uses a block lattice. It must include an array of independent nodes, each who have their own copy of the data. Okay, this is where the resiliency comes from, because if we have a submajority portion of those nodes go offline, we can still carry on. The transaction platform will continue to work the way we expect it to, right? It must include a consensus mechanism by which the nodes agree on changes. So this is how all the nodes decide what's true and what's not true. You want to make a transaction from A to B, they all have to agree that you have the funds online in order to make that happen. And they have to agree that you did in fact decide to make this happen and that the funds actually wound up at B, right? And in order to make this all true, there has to be a costly commitment, which makes an honest consensus the only rational strategy. So in Bitcoin, for example, we have the proof of work protocol, which burns electrical power, which is costly, and that is used to drive the hashing algorithm, which secures the blocks in the actual blockchain that Bitcoin uses. together, and then that commitment makes it rational for all the nodes to do this honestly, right? If you don't have that, then you could have some group of nodes who decide, well, we're going to rewrite the blockchain and we're going to send all the funds to ourselves. So these are the things you have to have a blockchain in the larger sense of what we typically talk about when we use this term. And again, the data structure itself, maybe it's not actually a data structure blockchain. There are other ones in use. Okay, so this gets us to the property of decentralized trust. You can trust the network without trusting anyone on the network. And the question is, why, right? Why can you actually trust the network if it's potentially made up of all these, actors that you don't know, have never met, and might have no reason to trust, or do have no reason to trust whatsoever, right? And the answer is that costly commitment is knit into a permanent record, and undoing the record is impossible if you don't pay a higher cost than what's already knit into it. So as time goes by, this becomes untenable. When Bitcoin was first released, it was Satoshi by himself in his basement, creating these digital tokens for evidently no good reason. And had Satoshi on his own or her own decided to rewrite the blockchain, that would have been, that could have been done very easily. Once the protocol was out in the world, once there were more nodes operating, once we had that distributed consensus mechanism happening across multiple independent nodes who are all making this costly commitment, now we have the property of decentralized trust. And now we can do transactions with people we don't know, because we know the network itself will make the transaction go through regardless of what that other person does. Okay, so in order to kind of get your mind around why we're doing this, I just want to talk a little bit about what an actual transaction is. So a transaction is an exchange which manifests a gain in trade, and it requires that we are operating in different contexts. And a great example is an airline ticket. Every airline ticket has a flight and it has a seat. And you can't actually trade flights with someone who's on the same plane as you. It makes no sense. It's a semantic zero. You can trade seats, and if you like the window and someone else likes the aisle, and you have the aisle seat and they have window seat, you then create a gain in trade by exchanging like this. And this is how human civilization has been built, is because for 10,000 or 20,000 years, our ancestors have been able to realize gains in trade, which lets them economically specialize, which increases productive efficiency, and all that accumulated value is what has built civilization over that time frame. So it's a really key concept, and it's something I certainly didn't really think about very much until I started digging into it. Like, why do things work like this? The original transactions were barter transactions, right? And when we trade A for B, we realize the gain in trade immediately. So there's no trust required. If I'm giving you apples and taking grain, that transaction happens all at once. So I can go away, and assuming that I checked the grain before I took it, then I'm going to be confident that I gained the value I thought I was going to gain, right? However, the problem with barter is that you need to find someone who needs the exact trade. And that is very difficult in the modern world. If you need a set of tires for your 1995 sports car that you're renovating, and someone else needs a refrigerator, well, you better have the refrigerator they need, and they better have the tires you need, or you can't do that. That's a very hard barter transaction to find. We invented currency, and that enables a much easier transaction, because I can just, sell whatever I have to whoever, I don't care who. I take currency, and then I can buy with that currency, I can buy from you the tires that I need. So this greatly increases transactive efficiency. It lowers transaction costs, and again, it's what makes civilization go round. There are a bunch of ways to skin this cat, and historically there have been a lot. Right? Here's historical currencies. On the left, you have cocoa beans, which the Aztecs used as currency. Below that, you have these copper stylized spade heads that they used in I think Zhou Dynasty China. In the middle, you have these hybrid systems, and the systems on the left are fully decentralized because anyone could grow cocoa beans, anyone could mine copper, and that was just the universal trade currency that got used. In the middle, you have some degree of centralization happening because in ancient Rome, they used gold and silver coins, but the coins were actually authenticated by the emperor, right? The emperor would stamp their face on it, and that certified, yes, this was in the name of the emperor, this much gold of this purity or this much silver of this purity. You also have below that, you have a pound sterling note from the days of the Hudson's Bay Company. And again, these were issued by the company for the most part, in exchange for beaver pelts. And the idea here was that the company was certifying that, yes, you delivered this many pelts, so you were entitled to this much worth of goods from the company store. And then, but the beaver pelts were a physical good. And so this is still a hybrid model. And then we moved in the modern era, we've moved to fully centralized fiat currencies where the government just prints what they want and they make it hard to counterfeit, and we all use it. And that can come in the form of physical cash, or it can come in the form of electronic currency. In all of these cases, there are trade-offs. So if you're using the fully decentralized system, this is really great, but you're subject to the authentication of, is someone adulterating my copper spade head? Is it only 50% tin? And even the Aztecs had a problem because people would fill up the cocoa bean husks there with mud and pass them off as real. With centralized currency, it's a little more authenticated because it's hard to get the technology to do the authentication. And of course, the central authority is going to make it illegal and impose penalties for that. But that comes with a cost. And so you reduce transaction costs on the one hand, but you increase them on the other hand. And then with a fully centralized system, it's really very efficient because you don't have to mine and refine gold. You don't have to grow cocoa beans. You don't have to trap beaver pelts. You just make these notes, right? You just print money. And that's very efficient. The problem is, of course, that because the only restraint on this kind of currency is the government, sometimes governments print more money than strictly they should. And, we're living today through an inflationary period for that reason. We're very fortunate that we live in Canada where, the government has generally decent fiscal policy, but there are many, many examples of governments printing their currency into worthlessness, starting with, the Weimar Republic after the First World War in Germany. Argentina has done it 6 times. Zimbabwe has done it. Bolivia or Ecuador has done it. And over 50 currencies have absolutely vanished since the end of the Second World War. So governments don't really have a great record. So we gain the efficiency by having the centralized issuance, but we also accept inflation, and in some cases you in fact accept inflation that can destroy all your savings. Right. So, wrong way. Excuse me. Oh, wait. There we go. Okay, so what we are enabling with blockchain is electronic transactions peer-to-peer with no third party in seconds around the world, right? Why is this better? Or how is this better? And The answer is my favorite statistic around this is actually comes from the transportation industry. So the global transportation industry annually absorbs about $10 trillion from the global economy. That's roughly 10% of the 90 something trillion that the global economy is. And this kind of makes sense, right? Because you have to move goods and services around the world, or goods and people around the world. And it's going to cost money to do that. And, 10% kind of intuitively feels about right. And in order to accomplish this, there is a massive amount of physical infrastructure, the container ports, rail lines, airports, aircraft, container ships, trucking firms, the entire road system, the entire fossil fuel industry that powers all those things. It's a huge infrastructure investment. And the cost to us, including their profit, is $10 trillion. If we look at banking, if we look at transactions, they absorb $2.5 trillion for essentially sending email, right? Because an electronic transaction is really a glorified email. And this is orders of magnitude less infrastructure. And so the difference between what this costs them and what this costs us is measured in monopoly profit, essentially, to the transaction industry writ large. And I mean, it's not strictly a monopoly. You can choose MasterCard or you can choose Visa. Uh, you know, you can choose one of the big five banks here in Canada, or you can choose one of the smaller alternatives. But very much because the transaction industry controls the transaction rails, the transaction industry is able to take these monopoly profits, and there's not a lot we can do about it until we have a blockchain. So the value of blockchain is, really quite simply, we can do these transactions independently. So the transaction cost can go way down. What this enables, first of all, greater economic efficiency. Second of all, greater financial inclusion, because there are 2 billion people on this planet who do not have access to financial services. And that puts value in your pocket, in my pocket, in everyone's pocket. And it increases the economic efficiency of the globe writ large. Now, blockchain itself comes with transaction costs, and anyone who's worked in the space for any length of time at all realizes that sometimes those transaction costs can spike very high. So there are use cases where, it's better or worse, but the ultimate reality is that by providing an alternative to the conventional system, we at a minimum force it to change the way it works. And as we in the blockchain space get better, those costs are driven down. And in fact, at Dandelion, that is our exact driving force. We have what we believe is the physically most efficient transaction platform that you can build. Mathematically, for those who are into computer science, we reach finality with big O1. That means that it's as efficient as it can get. And when the cost of transaction is driven down to the cost of computation, which is what this does, then you will see all those benefits realized. Okay, so that's the value of blockchain. But there is actually more to it than that, because when I originally defined it, I said, well, it's a secure, resilient transaction platform with the property of decentralized trust. But it's actually more than that, right? This is a secure, resilient computation platform with the property of decentralized trust. A transaction is just a specific form of computation. And if Satoshi's brilliance was realizing that you could use the blockchain data structure, you could use the proof of work protocol to make this transaction platform that was independent of any third party. Vitalik's brilliance, Vitalik being the guy who came up with Ethereum, was that you could extend the transaction paradigm to cover any computation. And so what this enables, first of all, is smart contracts. So what Alex was talking about was essentially a smart contract lending platform. And that enables you to automate a process. So exactly as he described, you have a traditional contract and you would have to come to agreement. You'd have to write out the contract. There'd be some third party who covered the execution of that contract. And with a smart contract, you can set that up and it runs independently. So we eliminate that third party again. We eliminate the third party's costs and we eliminate the third party's profits, which lowers the cost for all concerned. That is a huge win for everyone who wants to transact. But there's actually more than that, because we can use these smart contracts to build a smart market. So this is a smart market that we're putting together for a client of ours. I had to block their name out, but they are looking to export about 1,000 head of beef a day from South Africa to China. And in order to do this, they need to have that beef meet a whole bunch of regulatory requirements about the way it's handled, treated, the antibiotics used, any contamination that might happen. So there's a whole bunch of authentication pieces that have to be in place there. Is the vet who administered the vaccine, is that actually a vet? And what we can do is tokenize all this and we can put it into smart contracts. We can track all the cattle individually. We can track, the various farmers individually. We can track the markets individually. All of this needs insurance because sometimes disasters happen. So you can then create an insurance smart market that runs on top of that so that through the whole thing, everything is covered off. And what you come up with is this interconnected system that can run without further intervention. And any farmer can participate in the market just by, basically signing up electronically, getting an RFID ear tag for their cattle and saying, I want to sell into this market. And this is really powerful for a place like South Africa because they've been raising cattle there for 10,000 years, but they have not been participating in international markets for very long at all. So this allows us to bypass all of the intermediaries who stand between that farmer and the receiving market at the far end and automate the process. That delivers more wealth to the farmer. It gives better assurance to the customer of the quality of the product they're buying. And it allows a really detailed data analysis of the entire process with a granularity that simply did not exist before. You could have people, for example, in the insurance market, you could have people who just want to participate in the insurance market say, okay, well, I'm going to insure this particular cow that I know because I'm in the village with the farmer who's raising that cow. And when the cow is delivered, the insurance contract pays out to the person who put the insurance in, or if the cow actually, something goes wrong, the cow dies or is otherwise unable to get to market, then the insurance pays out to the farmer. And this is very straightforward to automate. In this particular application, we're looking at actually using facial recognition for cattle, which is a thing. And so you just have to snap a picture with a smartphone. So the farmer can run the entire operation off a smartphone. And even though they don't have a great deal of technology there, one thing they have done is leapfrogged us in terms of communications technology. Everyone has a smartphone. This is just one example of what you can do with smart contracts with smart markets. And again, Alex's presentation was absolutely textbook excellent example of how you can take advantage of this technology. So in order to make smart markets work, it's a little more complex than simply the blockchain. You do need other components, and here are the major ones that you need. So you need a way to securely tokenize whatever it is you're going to be tracking. If it's cattle, it's an RFID ear tag. It might be an RFID sticker for a product. It might be a GPS transponder for a rail car or a truck or even a package. But whatever it is, you need a way to get the individual items tokenized so that they can then be dealt with in the smart market. The next thing you need is secure data feeds. So we call these oracles, and an oracle is essentially a source of information which also has the property of distributed trust somehow. And how this is worked out depends very much on the exact application. But one example would be the weather service. So if you have a whole bunch of temperature sensors in an area, a very common use of temperature information is to pay out contracts on raising chickens, because if it gets too hot, the chickens don't do well, you're going to get less yield. And so if you have all these sensors around, then you're measuring each sensor. You can actually build a distributed trust network, which is going to give you information on the local temperature in a whole bunch of areas, which is going to allow you to actually automate the payout of these contracts. And with some clever techniques, you can actually avoid spoofing and other problems where someone might want to interfere with that. The final thing that you really need is a secure event trigger, and this is going to come from the Internet of Things. Again, it's going to be very application specific, but an excellent example is simply, when we deliver the cow from the farmer to the actual market, you snap a picture with your smartphone, and the farmer goes, click, that's my cow, and the receiver goes, click, yep, that's the same cow. Transaction is completed, and everything else pays out or does not pay out exactly automated through the smart market. So this is what we can do with this technology. It's really exciting. Again, we're actually getting to launch with our own platform this week, and we've signed up our first customer for a smart market. We're working on a second is very close, and there's some more in the pipeline, and it's going to do very well for a lot of people. But the real bottom line, right, the value of blockchain is this. You can open markets, you can bypass monopolies, you can reduce business friction, and you can enable financial inclusion. So that's my presentation, and thank you very much.